let's say you're given CO2 gas at 25 degrees Celsius and 700 millimeters of pressure. Right there. Determine the density that the CO2 would have under those conditions. From the ideal gas law, PV equals nRT, we need to convert, now watch me close, we need to convert this to a density relationship. Now what is the definition of density? We all know it's mass divided by volume, yes? Okay. Now, when you look at the ideal gas law, the term that contains mass numbers is the n, little n here, which is, of course, moles. And we know that moles is mass in grams divided by formula weight, by definition. If I substitute this mass over formula weight into the position for the moles, I will obtain PV equals mass, I'm going to write it out, divided by formula weight times R value times the Kelvin temperature. I need to convert this relationship now so that it shows mass over volume. Now, I'm going to show you a way to do this. Once you get this far, you really want mass volume on the left side of the equal sign, everything. So, but I'm going to put it on the right side because I can divide both sides by volume. See, mass and volume. And so I'm going to put this over here, make a little space in here, make a mass divided by volume right there. Okay, so volume's no longer on the left of the equal sign. So I put it over here. Everything else goes over there with the pressure side. So what do you have to do mathematically to get everything else besides mass and volume to the left side? Well, I've got to get formula weight, multiply both sides, so I have pressure times formula weight right there. And then I divide both sides by R and T, and we have the equation for density. And you simply substitute the values given in the problem. Now, some of the problems may come just give you a formula, and if they don't give you the formula weight, you got to certainly calculate it. So this one is 44. Formula weight of CO2 is 44 grams per mole. And so now we can calculate the density of our CO2 in this problem by plugging it into this expression. Pressure at 700, that would be equal to 700 over 760 atmospheres. Okay, so pressure I want to put into my formula is 0.92 atmospheres. Formula weight for this is 44 grams per mole. 16, 16, 32, carbon's 12, 32, 42 for 344. Right there. That's not 144. R value is the gas law value, 0.08206 liter atmospheres divided by mole Kelvin, right there. And finally, the temperature at 25 degrees, you add 273 And so we have 298 Kelvin to put in there. Okay, I get 1.66 grams per liter. You can count on having one of those on test day. The issue that you need to focus on when studying this problem is how I get from the ideal gas law to the relationship that provides you density. Keeping in mind that density is a mass issue, mass volume issue. It transitions from here to the density equation through substituting mass over formula weight right there and rearranging, see, this equation into this expression right there. Now, knowing that you're going to get a problem on this exactly as I've just given it to you, change the numbers, use a different gas or something like that, you can memorize the formula if you need to. You won't have to worry about derivation. It's always good to know where it all comes from, though. Any questions? Check the textbooks if you have them. Go online, molecular worksheets, molecular weight and density from ideal gas law. You'll get so many you can choke to death. Okay? So you can prepare yourself quite well. These are easy. These are gimmies. Because I'm not going to make them any more difficult than this. Okay? You're seeing exactly what you're going to get. The second specialty problem is determining formula weight. Let me write my title. In the same capacity, we need to generate an expression that will give us formula weight. And you'll have data that you'll extract from a problem, and you'll recognize from the problem. Of course, it's going to say calculate the formula weight. So, I mean, you'll know exactly what you're after. So, the ideal gas law, PV equals nRT. Formula weight, again, is in the mass relationship in this expression. Okay? Moles is a mass divided by formula weight. Mass in grams divided by formula weight, parenthesis, RT. So with this section and this section of the equalities, we'll set these two equal and solve for formula weight. So I'll take PV equals mass over formula weight times R times T and solve for formula weight. Well, let's just multiply both sides by formula weight and divide both sides by pressure times volume. So I will have formula weight is equal to M in grams times R value times T divided by pressure times volume. Now, keep in mind the units associated with the variables in there must be compatible with the R value in this problem. Your volume must be in liters. Your pressure must be in atmospheres. You must be in moles. Well, that's going to be one that's going to be retained. And temperature has to be in Kelvin. So whatever you're given up here in the problem, you have to convert all your data to those Okay, you're given a problem and you extract, what do you need to extract out of this equation? Well, the problem needs to give you mass, temperature, volume, and pressure, and the R value will be on your reference sheet. So you don't have to worry about that. I'll write it in here anyway. Be careful, move slowly but deliberately in substituting numbers, data. Use your units because they will algebraically tell you if you're working the problem correctly. Because in this, if you're going to come out with formula weight, what are the units? Grams per mole. You come out with something else, you might recheck your placement of data. Okay, so our formula weight of this is mass. Well, tell you what, let me make the conversions first. Plus 273, we'll take this one to 373 Kelvin. 755 millimeters is 755 over 760, and now we're in atmospheres. This gives us 0.993 atmospheres. Divide this one by 1,000, 237 liters. Mass, you don't have to change that one. Well, they may give it in milligrams. Well, you got to convert it to grams. And of course, you list the R value as given in your reference sheet. Okay, now it's just a matter of substituting your data given into the formula weight expression. I'm just going to use mRT over P times V. Mass is 0.548 grams. R is 0.08206 liter. Atmospheres, mole, Kelvin. Temperature is 373 Kelvin. Pressure is 0.993 atmospheres, and your volume is 0.237 liters. Once you get the appropriate data in the proper place, then cancel your units and check to see that you have grams per mole. So liters will cancel, atmospheres and Kelvin. So we're left with grams per mole, which is the appropriate units. I get 71.3 grams per mole, so as it is.